Okay, our second example is for a convex mirror. Now, the one thing that we have to remember is for convex mirrors, the focal length is always negative. So the question states, a 10 centimeter tall light bulb is placed 32 centimeters from a convex mirror, and this mirror has a focal length of 20 centimeters. Once again, we're looking to determine the image distance. So we start by stating what we need to find. DI, the image distance, is question mark. And the object distance given in this question is 32 centimeters. And the focal length is 20 centimeters, but this is a convex mirror, so it's going to be negative 20 centimeters. We're going to once again use the mirror equation to solve this problem. And the mirror equation is 1 over f is equal to 1 over di plus 1 over do. Once again, we are looking for image distance, so we want to isolate the 1 over di. 1 over di is equal to 1 over f minus 1 over do. Now we can start to plug in our known values. 1 over di is equal to negative 1 over 20. We can move the negative value up to the numerator for a fraction, minus 1 over 32, which is the object distance. Now, once again, in order to subtract fractions, we have to find a common denominator. What I'm going to simply do is multiply this fraction by 32 and multiply this fraction by 20, and this will give us a common denominator. So 1 over di is going to equal negative 32 over 640 minus 20 over 640. So this gives us a 1 over di is equal to negative 52 divided by 640. So once again, we aren't worried about what 1 over di equals. We want to know what di equals. So all we're going to do is flip both of these fractions. Because the fractions are equal, we can flip both sides. So if 1 over di equals negative 52 over 640, then di over 1 is equal to negative 640 divided by 52. The negative sign can always stay in the numerator. Now, di divided by 1 is itself, so di is equal to negative 640 divided by 52, and di is therefore negative 12.3 centimeters. Now, the image distance, the solution, the image distance here is negative. When di is negative, the image is on the other side of the mirror, and it is a virtual image.